Welcome back to JRG Guitars. Today we have a follow-up to the video I posted with the Jimmy Page wiring kit that I put into that Les Paul copy that I got from Harley Benton.
JRG Guitars!
After posting the video of the LP Page wiring harness from 920D into my Harley Benton back there, I got in a comment discussion with someone who had installed that same kit in their guitar and noticed the high end really getting rolled off as the volume was turned down to the point where the tones were almost unusable. As I went back to look at my own and started to roll off the volume, I noticed the same thing. I had not noticed it at first, so I decided to install a treble bleed circuit into this kit. Now, a treble bleed circuit is a small resistor and capacitor wired up that go on the lugs of your volume potentiometer, and it helps the highs sort of pass through to the rolled off volume, therefore diminishing that high cut that you're in essence getting as rolling off the volume. I ended up getting two treble bleed circuits, one from StewMac that uses a orange drop capacitor, and another one from 920D that uses just a small ceramic capacitor. And this video will have me wiring those up into this guitar. I'm going to sort of Frankenstein approach it to where we can A-B these and clip them on and off to get some good samples and see if this treble bleed circuit will actually do the job. We'll be able to see if, as we roll off that volume pot, if the tones are still usable and those trebles and those high-end frequencies are able to pass through into our output project. That is coming up next. So as I look inside my control cavity, I can see here, these are the volumes. This is a neck volume and a bridge volume. And I've got to get to the lugs, which are down underneath, and it is going to be tight in there. I'll see if I can zoom in. Wow, it's tight. It is just a disaster in this tight control cavity. So I popped everything out, as we can see here. My plan is to just put a 4 or 5 inch piece of wire onto each lug that I need, and then I can just clip on the treble bleed circuit to really A-B. I want to be able to A-B both ones on the neck and the bridge pickup and get a good idea as to what it's really doing and how it's sounding. So we're going to just put those little lengths of wire on there now. Okay, so I've got my orange drop treble bleed circuit here. Just did a quick little solder joint on these two down to the alligator clips with a quick solder there. And then I've got my regular one, tiny little guy. God, this is nice because it's super small. If I can get it in the cavity, it's going to take a very small room. Again, with my alligator clips, we're going to be able to clip this on and A-B them and see if there's any difference between the two. From what I had read online, they're going with the orange drop really doesn't give you anything. It's just an extra cost. These were about twice the cost. Got these from StewMac. They're about 10 bucks a piece, and these were even cheaper. StewMac did sell a cheaper one, but these were from the 920D guys, and they were really inexpensive. Alright, so I put a little bit of heat shrink tubing here on the connector, so when I clip on to the lug here, and then this will be all insulated so I don't ground out on anything inside the cavity. Did that on both of those. Okay, so here we are. We're going to do some tone samples. So I've marked on the front of the guitar the volume knob. So right now both volume knobs are turned on 10. And you can see I have a small piece of tape on both the bridge and the neck where that marking is. The other marking here is if I get all the way down to 0. So we'll be able to test this, in increments and see about where it is and how it sounds with and without the treble bleed. As I turn the guitar around, we you can see my Frankenstein approach here. So what I have is these two blue wires are coming off the terminals where I will hook up the treble bleed for the bridge pickup, blue for bridge. I just selected my red wires for the neck pickup. So with no wires connected, basically there's nothing engaged. But when I clip on my treble bleed circuit that I have right here with my alligator clips, I can click it in and out. So I will record some samples with and without. I'm going to also fire up in my DAW a live EQ so we can see where these frequencies hit, and we'll be able to see what we're getting and what we're losing and how all that works. So I'm going to rig all this thing up, set it up, and get some samples going. Okay, so here we're starting out, volumes on 10, starting on the neck pickup with no treble bleed circuit. This is just our reference for what it sounds like, what we're trying to get away from. This is our reference for what it sounds like at bass stock levels. I'll turn the tone down by 2. Now by another 2. Now we'll go down by another 2. And now by another 2. This is now just volume on 2, barely cracked open. That demonstration was pretty revealing in showing that as we rolled the volume off, the high end really started to drop off in the signal. What I have up on the screen here, and this is just looping back and forth here, or looping again and again here, the various performances with the volume on 10 down to 2. And you can really see that at about 1K on the EQ curve, we really started to lose frequencies above that. The overall signal gain of the signal really didn't drop off all that much. It was really just the high-end frequencies that were really being clipped off. Obviously, the amplifier and the guitar were the same with the exception of the volume placement. I tried to make each performance as similar as the next in terms of the attack of the pick to make everything as equal as it could. And these waveforms really show where we're losing the signal. So next I'll proceed with some A/B tests where we can clip in that treble bleed circuit. So I will go back and forth to stock sounds and treble bleed sounds, moving the volume around, and I'll have various samples where you'll be able to see with the graphic EQ where the frequencies are, and of course hear what the sound difference is. So each one will have a graphic EQ on the screen and a text on there as to what volume position and whether I am stock or with the treble bleed engaged. Alright, so that's just a few samples of the neck pickup in various A/B circumstances, and I think we can see the Treble Bleed Circuit is certainly a nice addition. The signal still darkens up as we get down to levels, certainly when we get down to a volume level of around 4, it's a little darker and we can't quite get it all the way as bright as it was when on 10, but it's way better than it was at stock levels, and it's now at least usable. So next up, we're going to throw in just a couple of bridge samples. I'm not going to go too in depth on the bridge pickup, and then I'm also just going to do a quick little A/B of the ceramic treble bleed circuit as well as that orange drop. I didn't notice a huge difference between the two. Well, there we have it. A very interesting experiment indeed. I think at the end of the day, the Treble Bleed Circuit is definitely an improvement to this guitar, and it's something that I'm going to have to experiment through other guitars that I have to see if it's something that would be beneficial to install into those guitars. I would say that through the experiments, the differences between the orange drop capacitor and the ceramic pass capacitor were really almost non-existent. So as always, thank you very much for checking this video out. Thank you very much for staying in here into the end of the video. If you enjoyed this video, I'd urge you to please hit that like button. If you'd like to see more, hit that subscribe button and even hit that bell notification button so you can be notified when further videos are coming out. We've got more stuff to come. As always, it's a learning process for me, and I'm happy you're along for the ride. So thanks again from JRG Guitars.